take a look at your 9.4 packet. On Monday's page, right up there at the top, you'll see our title for the week. We're dealing with factored forms of a quadratic. Now, we've been talking about this for a while now. Actually, this is, I think, the third week in a row that we've been talking about the factored form. So this is not new, but what we're going to be doing this week is we're going to be getting into many more details and into more challenging problems. So it's going to be useful at the start of our lesson today to just review what we know about quadratics, about both factored form and standard form, about when each of these is useful and why we care about factored form at all. So this is a recap of a chart that you saw last week. In fact, on Friday, you had to fill out a grid exactly like this as a review exercise by going back through your own packet last week and filling in these missing blanks. So real quick, I just want to remind everybody about the most important features of the standard form of a quadratic. A standard form of a quadratic is written in the form y equals ax squared plus bx plus c. And as I was walking around, I noticed that some students already wrote that in. I'm so excited to see that. We need to commit this form to memory. You need to know what this basic form looks like. And the reasons why will hopefully become clear later today. The standard form of a quadratic is helpful when we need to find a, b, and c. A, b, and c will be numbers, but they are numbers that give us a lot of information about the quadratic. Specifically, we can gain information like the y-intercept. The y-intercept is always located at the point 0, c. So that's one way in which a, b, and c can help us understand our quadratic equation. Another thing that the standard form helps us find is the axis of symmetry. The axis of symmetry is located at the point, or at the line rather, x equals negative b over 2a. And I didn't leave you guys a lot of room to write this in here, so just try to smush it in. And the axis of symmetry is very closely related to the vertex. Remember, the x value of the vertex is also equal to negative b over 2a. The y value is a little more, it's like once removed. You have to take the x value and plug it into the original equation to find the y value. Once you have the x value of your vertex, you plug that x value back into the original equation, and that's how you get your y value. Now, I don't have enough room to write all of that down, so I'm just going to write down plug x in. And if you want to make yourself a more detailed note somewhere on the margin of your page, then please. Now let's look over at the right and talk a little bit more about the factored form. The factored form of a quadratic equation is usually written like this: y equals parentheses x minus h, close parentheses, x minus k. So we've got two sets of parentheses, and inside each set of parentheses is a factor. These two factors are being multiplied together. Now, h and k are just numbers, but they're very important numbers that, again, give us some very valuable information about the features of a quadratic. So h and k are the first important things that this form helps us find, h and k. Well, what are h and k, or what do h and k help us determine about the quadratic? And that would be the roots. Specifically, the roots are, in fact, x equals h and x equals k. Given a quadratic written in this form, these two things are our roots. We have a lot of other names for roots as well. We can call them solutions. And solutions are written in the same form, x equals h, x equals k. But then also sometimes we refer to these as x-intercepts. And x-intercepts are written in a slightly different form. X-intercepts are usually written in the form of a point, which would be h comma 0 and k comma 0. Remember, because our x values are h or k, and our y value is always 0 at the x-intercept. So that's where those points come from. So I'll be honest, one of the main reasons I wanted to start today's lesson off with this chart was because on Friday, when you guys were filling out these charts on your own, some students were struggling to come up with 4 things to put on these lines. It's useful to summarize our knowledge, kind of tie together everything we learned that week. And it was a little difficult maybe to find everything in the packet because some of it was hidden on Wednesday's page of the packet. But this is all of the information that I was hoping you would find last week when you filled in your review page. Okay, so the last 2 lines here that are still blank are more of a lead-in into what we're going to be talking about today. So we have these 2 forms. We have standard form and we have factored form. In order to go back and forth between the 2 forms, we learned a couple of methods last week that we practiced quite a bit. To go from factored form into standard form, basically you're starting from a point where you have 2 factors being multiplied together. And in order to expand that out into the standard form, the method we used was multiply. We just multiplied those factors together. Multiply. That's it. Now let's imagine we wanted to go in the other direction. We wanted to go from standard form into factored form. This is the exact reverse process. The reverse process of multiplication is factoring. So the process we use to go from standard form into factored form, we just say you factor. And hopefully that's pretty easy to remember because it's how we get into factored form. You factor to get into factored form. Hopefully not too tough to remember. This is what we're going to be practicing today, factoring. Solving quadratic equations by putting them into factored form and then finding our roots. So I wrote a list here to remind you of the steps. We've been doing a ton of practice of step 2. We haven't talked as much about step 1. We briefly got into it on Thursday, but we haven't spent a ton of time with this. So that's primarily what we're going to be practicing today. Take a look at step 1. Step 1 is to put the quadratic equation in standard form equals 0. Think about what we just wrote down. We know how to go from standard form to factored form. But in order to go from standard form to factored form, you have to start in standard form, right? And so if you're looking at some of the examples that lay ahead, you might notice that these do not start in standard form equal to 0. Take a look at example 1, for instance. Why isn't this in standard form equals 0? Can I get a volunteer to tell me why this is not standard form equals 0? Because it doesn't equal 0. It's that second part. We need to have a 0 on the right-hand side. So let's change this so that it does have a 0. In order to have a 0 over here on the right, we're going to need to find a way to cancel out or undo the 3x and the negative 10. All we need here is addition and subtraction. That's what we're going to use primarily to rearrange these. So let's undo the positive 3x by subtracting 3x from both sides. And let's undo the negative 10 by adding 10 to both sides. Once we do that, on the left, we should have x squared minus 17x plus 70. And on the right, all of those various terms cancel each other out, which was by design. That's how we intended it to happen. Now this is standard form equals 0. So now we factor. This is step 2. We factor, and we practiced this a lot last week. So draw your generic rectangle. In the first box, we'll put our x squared. In the last box, we'll put our positive 70. And then we need to come up with a list of numbers that multiply together to give us positive 70. So to be positive, we're going to need a plus plus or a minus minus. And to equal 70, our list will include 1 times 70, 2 times 35, 3 times anything? No. 4 times anything? No. 5 times anything? Yeah, 5 times 14. And we can use a calculator on these if we don't have all of our multiplication tables memorized. What about 6 times something? Does that work? No. 7 times something? That should work. 7 times 10. So you're going to have to come up with these lists on your own when you're factoring. Your calculator might be your friend on stuff like this. All right, so take a look at our list. We need to figure out which one of these items on the list is the one we want. So what can we look at to help us decide? This middle term right here. The negative 17x in the middle of our standard form comes from these two pieces. So whatever the two numbers are that we put in to our factors are basically going to end up right there in these two boxes. So we need to pick two numbers that are going to add together to give us the negative 17 that we want. So once you go through that logic, it won't take you long to figure out that the two numbers we need are 7 and 10, because 7 and 10 add together to give us 17. And if in fact we use a negative 7 and a negative 10, then we will get a negative 7x and a negative 10x, which add together to give us negative 17x. So it was the minus minus that we ended up using, not the plus plus. Well, the whole point of that was to actually just write this in factored form. So let's go ahead and do that. Our quadratic equation now becomes x minus 7 times x minus 10 equals 0. This is factored form. Now that it's in factored form, we can very easily find our roots. If two things are multiplied together and it equals 0, that means that one of those two things has to be 0. So one of these two factors has to be 0. And we can very easily solve these and end up with our two roots. You might notice that I didn't use the shortcut this time, but feel free to use that. If you're comfortable with it and you know you can just switch your signs here and end up with the root, feel free to use that method. You don't have to write this all the way out. On the right-hand side of the page, I left a kind of an empty box here. This is for you to take notes. So later in the week, you're going to be working on examples like these on your own. And if you get stuck on a problem, it might be useful for you to turn back to this page and try to find similar problems and read your own notes about how to solve it. So make yourself a note here. What did we do in this problem that was a little bit different or a little bit unique? The first step was you have to get 0 on one side. You might want to make a note about to do so, you undo all the terms on that side. These notes are for you, right? These notes are not for me. So if these notes seem super obvious and totally unhelpful to you, don't write them down. Put something more valuable in this space. So these notes are to help you remember later what you need to be doing in these problems. Maybe you need to make a note to yourself that's, anything you do to one side, you have to do to both sides. Maybe sometimes you find yourself forgetting that. So you might want to make yourself a note. Whatever you do to the left, you have to do to the right. Whatever you do to the right, you have to do to the left. So make yourself some notes that might help you on a problem like this. All right, let's move on to example 2. In example 2, something weird is about to happen. So just hang tight, bear with me while we explore this problem. We have a similar issue with example 2 where we're starting out and it's not in standard form equals 0 because it's not equals 0. So let's put it in standard form equals 0. Let's undo the positive 4 that's on the right-hand side. If we do that, we will subtract 4 from both sides, which is going to actually affect both sides of this equation pretty significantly. The 4 and the negative 4 on the right will cancel and give us 0. But also the 4 and the negative 4 on the left will cancel. So what we end up with on the left is just an x squared plus 9x. Can I get a volunteer to tell me whether this is in standard form? Do we know? So remember what standard form is. Standard form is ax squared plus bx plus c. So my x squared and my plus 9x kind of line up here and here. But what about this last bit? What's going on here? Where's my c? Does anybody have any thoughts about what's going on here? Joel, what are you thinking? Exactly right. We do have a c value. Our c value is 0. So this is in standard form, but this standard form happens to have some invisible components, which is a weird thing to think about when you're factoring. Okay, factoring involves us to remember where our first piece goes, where our last piece goes, and if one of those pieces is missing from our equation, it's going to make it very hard to fit things into the right spots. So here is my advice to you. Rewrite your equation so that you have all 3 terms of the standard form represented. It might feel silly, but if your c value is missing, go ahead and put a 0 in there for c. So you would write it as x squared plus 9x plus 0. And the reason we do that is because on the next step, when we go to factor, we always put the first term in the top left box, and we always put the last term in the bottom right box. If you forget to put your 0 there in your standard form, you might put the wrong number in the bottom right box. You might accidentally try to put a 9 in there, or maybe a 9x or something. The term that goes into the bottom right-hand box has to be c, okay? So I would recommend filling in your standard form with 0s if necessary before you go to factor. So we're looking at a unique factoring example that we haven't done just yet. Once you get to the point where you need to find 2 numbers that multiply together to give you that bottom right square, this becomes a pretty expansive problem. I need 2 numbers that multiply together to give me 0. But I can think of a lot of options. 0 times anything gives me 0. So my two numbers could be 0 times 0, 0 times 1, 0 times 2, 0 times 3, 0 times a gazillion. I just made that number up, but it could be 0 times anything. So we have an infinite number of options, and that is daunting. So it becomes even more important to remember how we have to narrow down our options. We do that by peeking at this middle term, the 9x. And again, you might forget that that's the middle term if you don't put your c value in there, that 0 at the end. So take a look at that c value. Remember, we need our two numbers to add together to give us that number in the middle. So we need to find two numbers that add together to give us 9, but multiply together to give us 0. So hopefully it's not too hard for us to figure out that we want 9 and 0. Both positive in this case. So if you fill in all of the squares in your generic rectangle, you'll see that 0x and 9x do in fact add together to give you that middle term that you need. And all of this multiplies back out to what you started with. In fact, on the bottom, everything's just 0. And on the top, you just have x squared plus 9x, which is what we started with. So we got there, we factored this. Let's actually write it out in factored form. Once we have converted this into factored form, then it's okay to go ahead and simplify things a little bit. Like this x plus 0, at this stage in the problem, we won't write it like that. We'll turn it back into just a regular old x. And now it's time to split up our factors into their separate individual mini equations. X plus 9 equals 0 and x equals 0. And we get two answers. X equals 0, of course, we didn't have to do any work there. And x equals negative 9. If you could get that last step done without any scratch work, you're fine. Go ahead and do that in your head if you know the pattern and you want to stick to it. But now that we've finished the problem, let's make a note to ourselves on the side about what just happened here. Put it in your own words, write whatever's going to help you remember how to do these problems. I'm going to say something like, make sure all three terms of standard form are included. If C is missing, put 0 in. I don't know, something like that. Write whatever will help you remember. All right, I'm going to go ahead and move on to the next example. In the next example, something quite similar is happening in example 3. We need to get this into standard form equals 0. So let's start by undoing the 6x. Well, as you can plainly see, on the right-hand side, we end up with 0. But on the left-hand side, something happens as well where the 6x and the negative 6x cancel each other out and they disappear. So there's nothing there in that space anymore. So I'm going to write this in Scratch and then I'm going to erase it. Remember your standard form, ax squared plus bx plus c. This is why I said at the start of class, you're going to need to have this form committed to memory because we'll be thinking about it a lot. Standard form starts with an x squared, and then it has an x, and then it has a constant. That c at the end is just a number. Looking at our equation, we have an x squared, and we have a constant. We are missing the middle piece. The middle piece is what's missing. So if we wanted to put this actually in standard form, we would need to write it as x squared plus 0x minus 25 equals 0. This is very similar to the last example, except instead of C missing, this was B that was missing. When we're just going to fill it in with a 0x. And then we can factor. Our first term goes in the top left box. Our last term goes in the bottom right. Notice that is a negative 25. So when you put that in the bottom right, make sure you put the negative in there. And now I'm going to make a list of factors that multiply together to give me negative 25. Well, in order to give me a negative number, one of them has to be a plus and the other one has to be a minus. But in order to give me a 25, we only have two options, which is kind of nice. 1 times 25 or 5 times 5. Can anybody foresee what's about to happen here? Does anybody want to make a prediction about what the answer is going to be? Well, if nobody thinks they know what's about to happen, I'm going to go ahead and use 1 and 25. If I use 1 and 25, that would give me a 25x and a 1x, and one of them would have to be negative. If I subtract 1 or if I subtract the 25, either way, I end up with a 24, like a 24x or a negative 24x. But that doesn't match my middle term. This obviously is not going to work out. What if we used the 5s instead? Let's see what happens there. I had a 5 and a 5. Remember, one has to be a plus and the other has to be a minus. If we play this out instead, we end up with a plus 5x and a minus 5x. Aha! I hope you're seeing it now. Positive 5x and negative 5x add together and cancel out. That's how we would have ended up with this 0x in the middle. Because we had a positive 5x and a negative 5x. They are exact opposites. They have opposite signs, but they have the same value, and they cancel out and give us 0x. So this is actually a perfect factoring. We are going to rewrite our quadratic in factored form. So that would be x plus 5 times x minus 5 equals 0. And at this stage, you can split this up into two separate little equations, and you end up with two separate answers, x equals negative 5 and x equals positive 5. So make yourself a note, move over to the other side of the page, write whatever you think might help you here. What did I write last time? Make sure all three terms of standard form are included. If C is missing, put 0 in. This time I'm going to say if B is missing, put 0x in. And very specifically, I'm going to say in the middle, because this would be our middle term. So we need to make sure it's in the middle of our standard form. Okay. In example 4, this problem might look simpler than it really is. So this is a quadratic equation. It starts with an x squared. X squared equations are quadratic. So we can solve this the same way we've solved all the other examples so far. Starting with getting it into standard form equals 0. So standard form equals 0 means we have to get a 0 on one side. Don't write this down, but look up at the screen. If I undo the x squared, then on the left, I would have negative x squared plus 16 equals 0. And I would need to factor this. But we haven't factored anything that starts with a negative x squared. And in fact, it's actually pretty challenging to do this. We don't like to factor when we start with a negative. So instead of undoing the x squared, now you can write this. Now we're on the right track. We can undo the 16 from both sides. That is a much more approachable way to tackle this problem, because x squared minus 16 is way easier to factor than negative x squared plus 16. We still have one more issue because this doesn't quite look like standard form equal to 0 just yet. We are missing a term. Are we missing our first term, our middle term, or our last term? Can I get a volunteer to tell me whether we're missing the first, the middle, or the last? Yeah, it's the middle. Our first term is always the one that has the x squared. Our second term is the one with the x. And our third term is the one that doesn't have any variables at all. So in this example, we have an x squared and we have a 16. It's that middle piece that we're missing, the one with the x. So when we rewrite this, we're going to put a plus 0x in the middle. Thank you for volunteering. And let's factor. In our top left box, we'll put x squared. Bottom right box, negative 16. Time to factor. So the negative 16x on the bottom right will have to be made up of the product of a positive and a negative. So 1 plus, 1 minus. And the numbers could be 1 times 16, 2 times 8, or 4 times 4. We need to choose two numbers that will cancel each other out and completely become 0, which is actually easy to do because we have to have one positive and one negative. And if we choose the 4s, that means we'll have a positive 4 and a negative 4. Those two things would certainly cancel each other out. Plus 4x, minus 4x, they go away. They're opposites. So we have factored this into x plus 4, x minus 4. And then we can solve. So we split this up into two separate mini equations, but I'm going to kind of skip a step. I feel like we're getting better at recognizing that pattern, and we know we just have to switch our sign. So we get our two answers, positive 4 and negative 4. I want you to think back to the beginning of this problem when we had 16 equals x squared. Many of you could probably pretty immediately recognize that 4 was going to be one of our answers. But negative 4 also ended up being an answer. And let's talk about why. If I take negative 4 and I plug it in for x, what happens when I square negative 4? What happens to the sign of negative 4 when I square it? Anybody? Kaylee, would you take a guess for me? Exactly right. If you square a negative number, it becomes positive because you're multiplying a negative to itself, a negative times a negative. So negative 4 squared becomes positive 16, just like positive 4 squared becomes positive 16. So these types of problems are going to have two answers. I'm going to make a note over on the side. Probably the most important thing that I mentioned during this example was when you have a choice about which side to undo, try to end up with a positive x squared. That's just a piece of advice from me to you. So just to remind you what happened here. In this example, on our first step, I could have subtracted x squared from both sides to undo the x squared. But then the x squared would be over on the left and it would be negative. And that is quite challenging to factor. We want to try to avoid factoring quadratic equations that start with a negative, if we can. So just a little note to myself in example 4, so I remember to avoid that in the future. All right, so that leads us into example 5. In example 5, we need to put this into standard form equals 0. So I'm going to have to either move all of the stuff that's on the left by undoing it, or moving all the stuff that's on the right by undoing it. Which side should we undo? Based on the note that I just wrote down about trying to keep a positive x squared, which side should we undo? Kendall?
Left and to the right.
Exactly right. Kendall says that we should undo the left side. I like that a lot because if I subtract 2x squared from both sides, over there on the right, I will end up with a positive x squared. If I tried to do this the other way around, we would end up with a negative x squared on the left, and we don't want that. So I'm going to go with her instincts. Let's undo all the stuff on the left. So we're going to add x to both sides, and we're going to subtract 4 from both sides. Everything on the left cancels. On the right, we end up with x squared plus 9x minus 10. And this is just a regular old factoring problem. We don't have to worry about adding in any missing terms. We don't have like a missing b or a missing c, which is nice. Let's fill in our generic rectangle as much as we can, and then we'll start making a list of numbers that multiply together to give us negative 10. Well, if it's negative 10, then we'll need a plus and a minus, one of each. And our options are 1 times 10 or 2 times 5. When your signs are different, you're looking for a difference. So it's the 1 and the 10 that give us a difference of 9. Because 10 minus 1 is 9, so the difference between 10 and 1 is 9. So let's use negative 1 and positive 10. That'll give us a 10x and a negative 1x. And hopefully you can see if you add together 10x and negative 1x, you end up with a positive 9x. Put it all together into factored form and pull your roots out of those factors. We all should end up with 2 roots. X equals negative 10 and x equals positive 1. If we talked about anything during this example that you think might be helpful to you as you're working through example problems this week, make yourself a note on the right-hand side of the page. put it in your own words. Give yourself a little tip about how to approach these in the future. Or if example 5 seemed pretty straightforward based on everything else we've talked about, maybe you don't need a note here. Let's look at example 6. I hope no one has tried to do this example yet because there's a typo in it. This should say plus 5x right here in the second piece. So it should say 4x squared plus 5x minus 14. At least I think that's what it's supposed to say. Let's cross our fingers and hope this works out. This problem was a headache in our first period class today. So let's try this. The main point of the problem that I wanted you to see here was actually the stuff that's going on over on the right-hand side. When you're out in the world and you encounter quadratic equations, they're not going to be handed to you in nice, neat, standard forms, right? They're going to be some kind of product of some real world stuff that's going down, and we're going to have all these weird formulas and ways of measuring things, and they might come to you looking nothing like a quadratic equation. So this one, for instance, has parentheses in it. The first thing we need to do is get rid of those parentheses before we even start rearranging things. So in order to get rid of those parentheses, we distribute the 5 using multiplication through the parentheses. So nothing is changing about any part of this problem except for where I'm multiplying the 5 through the parentheses. That will become 5x squared minus 5x. Everything else stays the same. And now it's time to try to get this into standard form equal to 0. So just like in the last example, we want to be choosy about which side we're going to move everything to. Let's pick the side where we're going to end up with a positive x squared. So notice that we've got a 4x squared on the left and a 5x squared on the right. Since the 5x squared is bigger, we want everything to end up on the right. So we're going to undo the left. Minus 4x squared from both sides. Minus 5x from both sides. And plus 14 to both sides. The left should always, or whatever side you're undoing, should always just end up being 0, so that works out well. And then on the right, we end up with just a 1x squared minus 10x plus 25. Let's try 2-factor. We'll use a generic rectangle. I feel like my rectangles are getting smaller and smaller. Let me revise that. On the top left, we'll put our x squared. On the bottom right, we'll put our positive 25. Now, I emphasized that it was positive. We have to keep that in mind. Our numbers are either going to be positive, positive, or they might be negative, negative, because 2 negatives can multiply together to give us a positive. So how are we going to decide? Well, look at the middle term we need to end up with. Notice it's a negative 10. Well, the only way we can end up with negatives in this problem is if we choose the negative, negative. I'm going to go ahead and write those in. Now let's talk numbers. 2 things that multiply together to give me 25. Either 1 times 25 or 5 times 5. Since both of our signs are the same, we're looking for 2 numbers that add together to give us 10, 5 and 5. Hopefully pretty easy to see. So factor, or rewrite this in factored form rather. X minus 5 times x minus 5 equals 0. And I do want to point out one thing. You could also technically write this as x minus 5 squared equals 0. That means the same thing because it's just x minus 5 multiplied to itself. But either way, you're going to have to end up with the root x equals 5. You don't need to write the root twice. You just need to write it once. So if you learned anything in example 6 that you think might be useful later, make yourself a note on the right-hand side in that box there.